So in the previous section when we did substitution, when we looked at a pair of equations, what we wanted to do was look at all four of the different variables and decide which one is going to be the easiest to isolate. Now with elimination, we're going to look at the pairs of variables and determine which pair of variables is going to be the easiest to eliminate. So if we have 2x plus 5y equals 17 and 6x minus 5y equals negative 9, when we look at these pairs, we've got a positive 2x and a positive 6x, and we've got a positive 5y and a negative 5y. So when we're looking to eliminate, that means we're literally looking to get rid of one of the variables. And we do this by subtraction. So since we've got a 5y and a negative 5y, we know that that's going to end up being 0y. So that's the pairing that we're going to look to get rid of. So to do this, we're going to draw our addition and subtraction bar underneath, and then whatever the signs are, we're just going to follow those signs. So positive 2x and positive 6x is 8x, because what we're doing is adding 2x and 6x. 5y minus 5y is 0y, so we're left with nothing for the y's. So we've eliminated the y's. Then 17 minus 9 is 8. Once you've eliminated one of the variables and you're left with just one, then it's just a matter of isolating that variable. So divide by 8, and you're going to get x is equal to 1. Now we take this solution here, this x equals 1. Now we go back and we do substitution. So you can choose either one of these equations to plug 1 in for. So let's do it for 2x plus 5y equals 17. So 2 times 1 plus 5y equals 17. So we get 2 plus 5y equals 17. 5y equals 15. And then y equals 3. So now we've got both an x value and a y value. The ordered pair that would be the solution is 1, 3. But again, we need to go back and we need to check and make sure that this is our correct solution, that we didn't mess something up along the way. Now, since we just used the 2x plus 5y equals 17 to find the y value, we've now got to move down to 6x minus 5y equals negative 9 to determine if this is a solution. So we're going to go 6 times 1 minus 5 times 3 equals negative 9. So 6 minus 15 equals negative 9, and negative 9 equals negative 9, which is a true statement. So that means that the solution is 1, 3. For problem number 2, we're looking at a word problem using elimination. This time we're told that there is a student play, and we've got two types of tickets. We've got adult tickets and we've got student tickets. The adult tickets are going to be $2.50 a piece, and the student tickets are going to be $1 a piece. In total, there were 101 tickets sold, and the revenue, or the money that was made, was $164. So before we can do elimination, we've got to come up with what are our equations going to be, because we ultimately want to figure out how many adult tickets were sold and how many student tickets were sold. So to do this, we're going to ask ourselves, how do we get to 101 total tickets? Well, that's just going to be the number of adult tickets plus the number of student tickets. So A plus S is equal to 101. Then the revenue is just the number of adult tickets sold times 250 plus the number of student tickets sold times $1, or just the number of student tickets sold, equals $164. So 2.5 A plus S equals 164. So remember, to do elimination, we want to have these stacked vertically first. So we've got A over A, S over S, and then our constant over the other constant. Then we want to decide which variable is going to be easiest to eliminate. In this case, the S's are going to be the easiest to eliminate because we don't have any coefficient besides 1 with them. But we do have one issue. They're both positives. So we've got to make one of them a negative in order to be able to eliminate them. Well, if you do something to one of the terms in an equation, then you've got to do that thing to all the terms in the equation. So what we're going to do is multiply this entire equation by -1. When we do this, we get negative a minus s equals negative 101. Now we can take the original second equation and the new first equation and then just do the operations. So 2.5a minus a is 1.5a. I'm going to write this as 3 over 2a because I know that I'm going to have to do some division, and I'd rather do the division with fractions than with decimals. Then s minus s is 0, and 164 minus 101 is 63. So now all I'm going to do is isolate a, and I'm going to know the number of adult tickets. So in order to do this, I'm going to multiply both sides by 2/3. The 2/3 and the 3/2, they cancel out, and you're left with a on this side. Then 63 divided by 3 is 21, times 2 is 42. So there were 42 adult tickets sold. Then the next thing we're going to do is we're going to figure out how many student tickets were sold. So we're going to take this number here and put it into this equation here. So instead of a, we're going to put 42 plus s equals 101. So s is equal to 59. So far we've got 42 adult tickets sold, 59 student tickets sold. We want to make sure that we've got this correct. So we would go back and work this out of this one. So 2.5a plus s equals 164. So I'm going to change this to 5/2. And I've got the adult tickets as 42 plus 59 equals 164. So 42 divided by 2 is 21, times 5 is going to be 105. So 105 plus 59 equals 164, and that is a true statement. 164 does equal 164. So I know that the total number of adult tickets sold was 42, and the total number of student tickets sold was 59. Okay, problem number 3 presents one of the same challenges that problem number 2 did, in that we don't have two coefficients that are exact opposites. So what we're going to have to do is make one of the coefficients into the exact opposite of the other one. So again, the first thing that you want to do is make sure that these are stacked. So we've got the x's over the x's, the y's over the y's, and the constants over the constants. Then the next thing we're going to do is we're going to look at which of these variables is going to be easiest to eliminate. Well, we've got a 2 and a 7 and a 15 and a 5. Definitely the easiest thing to do here is the 15 and the 5, because all we're going to have to do is multiplication against one of the equations. We won't have to multiply both equations like we would have to do if we worked with the -2 and the 7. So in order to make this into -15, we have to multiply that by 3. So that means we've got to multiply the entire equation by 3. So that's going to give us 21x minus 15y equals 51. Now what we're going to be doing is looking at the -2x and the 21x. So that gives us 19x, the 15y and the -15y, 0y, and that's going to be equal to -32 plus 51, which is 19. Now notice that I did not cross out or do anything to my original equation, because I want to go back and I want to be able to use that later on for either the next step in the process or to check it. So 19x is equal to 19. Pretty simple, x equals 1. So now that we've got the x equals 1, we want to take this and we want to put it back into one of the original equations. So either the -2x plus 15y equals -32 or the 7x minus 5y equals 17. Doesn't really matter which. It's going to work the same for both of them. So just whichever one you choose, again, doesn't really matter. So -2 times 1 plus 15y equals -32. So we get -2 plus 15y equals -32. So 15y equals 30, and y equals, 15y equals -30, and so y equals -2. So now we're going to go back and check it in the other equation to see if we've got the correct solution. So far we've got a solution of 1, negative 2. So since I just used this equation to find the y value, I'm going to use this equation to check it. So 7 times 1 minus 5 times negative 2 equals 17. So 7 plus 10 equals 17. 17 does in fact equal 17. So we know that the solution is 1, negative 2. All right, so for problem number 4, I'm going to go through the entire list of decisions that you need to make in solving one of these equations. So when we look at this series of equations, the first thing we've got to ask ourselves is, do we want to use substitution or do we want to use elimination? When we take a look at these, there's not one variable that we can see that stands out that says, I want to isolate this variable, because we're going to end up with fractions for anything that we choose to isolate. So that's not the best thing to do there. So elimination is going to be the better of the two options. Now, once we've chosen elimination, we've got to decide which one of these are we going to eliminate. I prefer to use the smaller pairing, just because you're going to end up working with smaller numbers. So I would choose to get rid of the y's because the coefficients on the y's are smaller. We've got 2 and 3 as opposed to 3 and 4. So in order to be able to do this, I've got to figure out what am I going to multiply the top equation by and what am I going to multiply the bottom equation by. You can do it to both of them. You don't have to end up with a fraction or anything like that. You can multiply both equations to end up working out using elimination. So I need to figure out what is the least common multiple of 2 and 3. Least common multiple of 2 and 3 is 6. So that means I want to multiply the top one by 3. And then I'm going to multiply the bottom one by negative 2. Because remember that I want one of them to be positive and I want one of them to be negative. So when I do this, 3 times 3x is 9x. Then we get 6y equals 3. Negative 8x. Negative 6y, and positive 4. Okay. Now again, I'm not going to do anything to strike out the equations, the original equations, because I want to be able to go back and take a look at those and see if, and use those for checking and use those for other parts of the solving process. 9x minus 8x is x. 6y and negative 6y cancel out. And you're left with 7, so x is equal to 7. Now we take that 7, we're going to plug it back into one of the originals. Go back into one of the originals. So we've got 3x plus 2y, so I'm going to go 3 times 7 plus 2y is equal to 1. So 21 plus 2y is equal to 1. So 2y is equal to negative 20, and y is equal to negative 10. Okay? So now the next step in the process, I've got x equals 7 and y equals negative 10. Go back and check this. So 4 times 7 plus 3 times negative 10 equals negative 2. So 28 minus 30 equals negative 2. Negative 2 equals negative 2. Checks out. So the solution is going to be 7 and negative 10. Okay, the last problem in this section is problem number 5, and we're given 2x plus 6y equals 18 and x plus 3y equals 9. So again, check to see that these are vertically stacked, which they are, and then which one are we going to eliminate? So the 2x and the x would be easy to eliminate, the 6 and the 3 would be easy to eliminate. Let's go ahead and do 2 and 1, since that's the smaller pairing in terms of the coefficients. So to eliminate this, I'm going to go times negative 2 on the bottom equation. So that gives us negative 2x minus 6y equals negative 18. Okay? Then 2x minus 2x is 0, 6y minus 6y is 0, so everything on the left side, both of the variables have been eliminated. Then I've got 18 minus 18 is equal to 0. So we end up with 0 equals 0. This is a true statement. Remember that if we end up with something that looks like this, where we have a number that is equal to another number, that means that our solutions are infinite. So we have infinite number of solutions here. If we were to end up with, say, like 2 equals 0, a statement that's not true, that would mean that we would have no solutions because the lines, if we were to graph them, would be parallel. In this case, when we graph these, that tells us that the lines are stacked right on top of each other. It's the exact same line, so they share all the same points. Therefore, the solutions are infinite.